Okay, so let's go through this. Integration, differentiation is introductory calculus. All you have to do, follow the rules. Once you know the rules, great, perfect, you're good to go. It's very important for you to follow the rules for this particular topic, right? So, how do we integrate 3x to the power 4? All you're doing, following the rule, okay? So this is indefinite integration. So you have to put your plus c. According to my rule, 3x to the power 4 would become 3x to the power 4. So n, this n is referring to my power, right? So according to my rule, is n plus 1. So that's 4 plus 1. And then I'm also dividing by n plus 1. So that's 4 plus 1 as well. Let's see. And what is 4 plus 1? 5.
Miss question. So miss, that means that the power would be what you divide by?
Yes.
Oh, okay, miss. That makes sense. Thank you, miss.
So is everybody good with this? This answer, this is my final answer. Or you could have written it as, just to tidy it up a bit. 3 on 5 by x to the power. Both of them are acceptable. So are you good? Yes? No? Do it again?
Yes, miss. I'm good.
What about the rest of people? You good?
Yeah, miss, that's a quite easy topic to understand.
Yes.
Well, this part of integration.
The whole thing is easy. You just need to understand what you do. Okay. It's the same thing we do in here. We're just following the rules. So 2x to the power 5. I didn't say it here, right? So in your paper, you'll actually see the integral sign and dx standing already. So you know that it's indefinite integration. When we start definite integration, you'll actually get to see the difference between definite and indefinite integration. You'll know when to put this plus c, right? So just for now, just know this is what we're doing. Indefinite integration. So you have to put your plus c. I'll show you what it looks like in our past paper. So, right. All we do and follow me. Hold on, people join in.
Excuse me, miss.
Yeah.
May I go to the bathroom, please?
So this is x n plus 1. N is my power. So whatever power you see here, 5 plus 1. And then you're also dividing by the same thing, 5 plus 1. Remember I told you this is indefinite integration. I'll show you how it's written on your exam paper so you know for sure that it's indefinite integration. If it's indefinite integration, make sure to put your plus c. So, of course, you can't leave it like this. You simplify even more to give 2x. 5 plus 1 is 6. 5 plus 1 is 6. Preschool thing, right? Plus c. But if you can simplify, you must simplify. You can't just leave it like this, right? So if I simplify this, I get a third x to the 6. Everybody good with that?
No, miss. Miss, I'm to the C at the end, miss.
Yeah, miss.
Wait.
In the yellow, miss.
After this.
No, miss, with the C, miss.
Um, Yeah. Is that how you pronounce your name? Catania. Catania. Is that how you pronounce your name? Yes? No?
Yes,
Did you do always remember plus?
yes, miss, that's how it's pronounced, Kitania.
Okay, nice. So I know that, wait, let me just ask. Did you do integration before? Yes? No? Did you?
Miss,
Did you do integration?
miss, differentiation.
You did differentiation, but not integration?
No,
Yes.
miss, we just reached integration. We're just going to start it for my class.
Oh. Well, let me just finish this up because
Miss, I understood what you just did on.
is she breaking up anybody else? 'Cause, okay. I heard what you said. You said that you understand what I did. If you look at this one, number 3, 2 divided by x cubed, there's a problem. What's the problem? You see this? This is not in this form. That's the problem. For now, if this is not in this form, I cannot work with it. I need to somehow get this 2 on x cubed in the form ax to the power of n. Does anybody have any idea how I would do that?
Miss, I think I have one, miss. It's 2x negative 3.
2x to the minus 3. Good job.
I got it correct?
Yeah.
Laws of indices, bro. Laws of indices.
Yep. Laws of indices. That's correct. So this is really saying, so remember, I cannot work in this form. I need it like this, right? So I can rewrite this expression here as 2x to the minus 3. Does anybody not understand how we got that? If yes, it's fine. I'll just show you real quick. Going once, going twice. Okay. Right. From here, all I have to do, follow my rule. Like I said, just following the rule. So a x to the power of n plus 1. N, which is my index, in this case it's minus 3. So that's minus 3 plus 1. And we also divided by minus 3 plus 1. Remember, I told you this is indefinite integration. Always put your plus c. You don't put that plus c, you get it wrong. Okay. So minus 3 plus 1, that's minus 2. So 2x to the minus 2 on minus 2 plus c. You could simplify that even more. I could get minus x to the minus 2 plus c. I mean, you could leave it like that, but I mean, you have to show something, right? Show your examiner that you know what you're doing.
Miss, we can cancel the 2's.
Yeah, I cancel them. So that's how I got minus x to the minus 2 plus c. But like I said, you can leave it like this. Or, you know, show off, you know what you're doing. X to the minus 2 is the same as saying 1 on root x. So I can rewrite this as 1 on the square root of x plus. How was that? Wait, what am I saying? Let me square root of x is x squared. But yes, you get the point. You can leave it like this, or you can rewrite it like that.
Excuse me, miss. So like,
Yeah.
you see how like you have the negative x to the negative 2 power minus. You can just say negative x to the negative square.
Mhm.
Okay, mate, thank you.
Are you able to annotate on it? Like on the screen?
Again, mate?
Are you able to annotate?
What is that? Miss, what I mean?
Right on the screen. See, explain
No,
how you
miss,
did
that's
form.
joules.
Wait, this right here?
No, miss, like I understand this, but like the
Wait,
person's writing on the screen is joules.
oh, yeah, I'm talking about this one, from this to this. He's not answering. Okay. How you changed it? This to this green part to this blue part. Oh, okay. So before I do that, everybody understands this?
Yes.
Yes, miss.
Okay. So, where did that come from? All right. So let me just explain real quick how I got it in that form. From our laws of indices, we know. So I'm just representing A as my base, right? N is my power. So 1 on A to the power of N is the same as saying A to the power of minus N. Therefore, so let me just use 1 in the numerator. If I say 1 to the power 1 x cubed, 1 on x cubed, so A is x, N is 3. According to my law, this would become A, which in this case is x, and then minus the power. So minus N, in this case, it will be minus 3. And therefore, if I have 2 in the numerator, 2 on x cubed, I put back my 2 here. So in this case, 1 is understood, right? 1 is in the numerator, so I put back the 1 here. 1 is in the numerator, so I put back the 1 here. It's understood. So 2 is in my numerator, I put the 2. And then according to my law, this becomes x 3 minus. You understand now? Yes? No? You understand?
Yes, miss.
Yeah, miss, he said in chat he understood.
That's the sheet. Yes, okay. Next. So let's move on. Rules, remember, oh my, why do I have integration? Just ignore that. Anyways. Right. So remember I was telling you there's some rules that you need to know. So technically the one I just showed you was the first one. But excluding that, these are the other rules. So number 1, if you're given some differences of terms to integrate, then you have to integrate each term. And you saw that when I did the example with 6x plus 1, this is the rule I was referring to. So the integral of f of x plus or minus g of x dx is equal to the integral of f of x plus or minus the integral of g of x. Just to give you context on how exactly that is applied, let's do this question. So say they told me to integrate 2x cubed minus 3x plus 1. My rule, sums and differences. I see a minus sign, a plus sign, so that implies a sum and a difference and a sum. According to this rule, nothing really changes. All I have to do is integrate each term. Use the law that I showed you just now, and you do it for each term. You find the integral of each term. Find the integral of 2x cubed minus 3x, 3x, and 1, right? So let's take it one step at a time. What's the integral of 2x cubed? Well, all I have to do is apply my rule. So remember the rule I was telling you about? Ax to the power of n plus 1 on n plus 1. And then, of course, a plus c at the end. So the integral of 2x cubed, a is 2, x to the power of n plus 1. In this case, n plus 1 would be 3 plus 1, right? So it's 2x to the 3 plus 1 on 3 plus 1. Hence, I have here 2x to the power of 4 divided by 4. And then you see minus 3x. So you put your minus sign and you integrate the 3x. Same rule. So I have my a, x. Remember, when you just see x by itself, it's implied that the power is 1, right? So saying 3x is the same as saying 3x to the power of 1. So that's 1 plus 1 divided by 1 plus 1. That's why I have here minus 3x squared divided by 2. Then you integrate the 1. Remember from the laws of indices, anything raised to the power of 0 is 1. So by saying 1 here, I'm implying x to the power of 0. X to the power of 0, according to my rule here, I add 1, and then I divide by this thing here. So 0 plus 1. 0 plus 1 is 1, so x to the power of 1, but of course, by our law of indices, anything raised to the power of 1 is itself. So by saying x to the power of 1, I really just mean x, right? And then 0 plus 1 is 1. But you can't leave it like this, you simplify. So if I simplify this, I get a half x to the power of 4 minus 3 on 2x squared plus x plus c. Everybody good?
Yes, miss.
That's one person, just one more person answer me. You good?
Yes, miss.
Okay. Now you try. Integrate this for me and tell me the answer. You have 1 minute. Okay, anybody has an answer for me? That was in 1 minute. But
Miss, it can't be 1 minute so fast. But also, currently working it out, miss.
okay. Well, first person to answer me, you could answer in the chat. Yeah, that's correct. So first person, Jano. Good job. You can move on to the second answer one. So just to pick up the pace a little bit, all I'm doing, following my rule. So this is 5x n plus 1, and in this case it's 2. So that's 2 plus 1, and I'm dividing by this thing. So 1, 2 plus 1. But then I also have to integrate this 4. And I'll get 4x to the 0 plus 1, 0 plus 1 plus c. This would simplify 5x cubed on 3 plus 4x plus c. Josh, how do you get done? How did you get the 4 to the power of 5 on 2?
What did I do to get that?
I don't know, you tell me.
As you see now, people can't add 1 plus 1 these days.
You said 1 plus 1 is 5. That is concerning. It's fine, it's fine. Okay, anybody has an answer for me for number 2? Or number 3?
Not yet, miss. On my way.
All right.
Miss, you see how like when that Brendan figure is gone, we get to actually do something in the class.
Yeah. Nobody finished with number 2 or 3?
Not yet,
Yes.
miss, not yet.
And channel wins again. Yay. Well, yeah, that's correct. So, since somebody already told me the answer, I will just write it. I could go ahead and answer the third one for me. Whoa, whoa. Wait, which one is that for? The second one? I mean, the third one?
The one I just sent, miss?
That's for this?
No, miss. I sent the first and second. But that second one looking suspicious, miss.
Wait, the 2x cubed on x plus 2 plus 3x squared on 2 plus c. That's for which one?
Miss, not number 2, miss.
I'm asking you,
Miss number 2, miss number 2, number 2.
x plus 2 is your denominator for number 2. Look at this.
Let me see. Oh, okay, miss. I see where I went wrong. But I have some suspicions, miss. Miss, somebody copy and paste. Please, I think somebody copy and paste my answer and put it right there after. Like they're both wrong, miss.
I realize.
But I miss. I found out my mistake. Thanks.
So, Jana gave me number 3 already. Can you explain to me how you went about getting that answer? You don't have to talk, you can type if you don't want to talk. I simplified the expression, please. How did you simplify that? How did you simplify this? Anybody has any clue how I would quote unquote simplify this?
Yes, miss. I think I have it.
What would I do?
So, miss, basically the number behind, like in front of the brackets. Well, behind it. I'm not sure where that is. But that number right before the brackets. It's supposed to be 1. It's assumed to be 1. So then we sort of like go in with the 1. So I forgot what the term is called again. Hold on, miss. Give me a second. Let me get that term. Expand the brackets. So you get 1 times 2x, which will give you 2x. And then you add like the power of x is assumed to be 1, so you add the 1 to that, and that give you 2x squared over 1 plus 1, which is 2. So 2x squared over 2 minus the 1 assumed to be behind of the brackets times the negative 3. Oh, fudge. I think I already went wrong. MS, I didn't even count the square at the back. My badness.
Yeah. Pay attention, to that, right? Unlike these, so if I put a bracket here, right? Let me just say this, actually, yeah. Unlike these, where it's two separate terms, right? So it's 5x plus 4, 2x squared plus 3x. But this one, it's in brackets, 2x minus 3, all squared. That's different. When we are integrating from what I showed you so far, you have to get it in the form ax to the n. That is not in the form ax to the n. There is a rule that I will show you later on how to solve expressions like that. But for now, we're dealing with the basics. To integrate, I need it in this form. As far as you know, I cannot integrate, like, as far as you know right now, you cannot integrate if it's not in this form. Of course, you'll learn otherwise. You'll learn about some more rules later on, but this is the basics. Must be in this form for you to integrate. Not in that form, cannot integrate. So what do? If you have an expression that is not in the form ax to the power of n, you need to find a way to get in that form.
This
So,
will be 2x squared minus 3 square.
no, that's a common mistake people do. 2x minus 3 all squared is not the same as saying 2x squared minus 3 squared. That's a common mistake, but no. Like John has said in the group chat, in the chat, I would expand the bracket. So 2x minus 3 squared is the same as saying 2x minus 3 times 2x minus 3. And if I simplify or expand my bracket, I would get this expression. This is 1. 4x squared minus 12x plus 9. Yeah. Now, this right here, 4x squared minus 12x plus 9, this is in a form that I can use. You might be wondering, how?
Quadratic?
What?
Quadratic?
Yeah, it's a quadratic. But for integrals, we need it in this form. In order to integrate, we need the terms in this form. By expanding my brackets, I did that. 4x squared, it's in this form. A would be 4, x, well, x is x, and then n is 2. Looking at this, I have minus 12x, right? A is minus 12, x, and n would be considered 1. In this case.
And the C value will be 9.
Can you repeat that?
As I say, well, the C value will be 9, I guess.
The C value would be 9. No, that's different. Like that C value is completely different from this right here. Like the C, you get the C after integrating. This expression right here, we didn't integrate it yet. So this is not the arbitrary constant I was talking about. You understand that?
Yes.
Okay. This 9 is also in the form ax to the n. A is 9, x, well, it's implied. X to the 0, because anything to the power 0 is 1. So by saying 9, I imply 9 by x to the 0. X to the 0 is 1. 1 times 9 is 9. So that's why this and this, they're the same thing. So now that I have each term, each individual term in this form, I can integrate. So Jules, you asked me to go over something. Go over which part? Like the holding? Hold on, I have people joining. The holding? Yes, holding. All right. So they require me to integrate 2x to the minus 3 squared. There is a rule that I would show you later on that you can actually apply when the expressions are in this form. But for now, we're dealing with the basics. What are the basics? You must know I must have my expression in this form in order to integrate. Each individual expression, so like you see when I have sums and differences, this is one term, this is one term. Each term must be in this form. That's the only way I can integrate. It has to be in the form ax to the n. This is not in that form because I see 2x minus 3 all squared. So what you need to do is find a way to put this into this form, where each term is in this form. How can I do that? I can simplify. How will I simplify? I expand my bracket. 2x to the minus 3 squared is the same as saying 2x to the minus 3 multiplied by 2x to the minus 3. That's the definition of squared, something multiplied by itself. Just like 2 squared is the same as saying 2 multiplied by 2, which is 4. 2x minus 3 squared is the same as saying 2x minus 3 multiplied by itself. So 2x minus 3 multiplied by 2x minus 3. But remember, I need each individual term to be in this form. I need to expand these brackets, right? When I do that, I get this quadratic expression, 4x squared minus 12x plus 9. Now, each individual term is in this form. A is 4, x, n, which is my power, is 2. So, okay, this part to test, it's in that form. Now I go to minus, how'd you get minus 12x? When you expand these brackets, so just erasing this, right? Didn't need to erase all that, but anyways. So I'm using the distributive law to expand, right? 2x minus 3, 2x minus 3. So how do you expand brackets? Distributive law, right? So I would take 2x by 2x, which would give me 4x squared. Then I say 2x by minus 3, which would give me minus 6x. Then I do the same for this next term. Minus 3 by 2x, which is minus 6x. And then minus 3 by minus 9 plus 9. Minus 6 minus 6x minus 6x minus 12x. Hence, my quadratic expression, or the expression that I'm now going to integrate, would be this. Are you good now? Yes, no? Are you good? Two? Yes, okay. That's it. Or you need me to finish the whole thing? Like finish, like do the integration of each two.
Yes, miss, please.
So now that I expand these brackets and I simplified and all that, the new expression that I'm integrating would be this, 4x squared minus 12x plus 9. And this is in terms of x, so yeah. Like we saw in this first rule, this is the first rule we applying here, right? If I have sums and differences, all I need to do, I'm still applying the same rule that I told you from before. So the ax to the power of n plus 1 divided by n plus 1 plus c. Same thing you're applying here. But when you see sums and differences, you must make sure to integrate each individual term. So in this example here, the terms were 2x cubed, that's one term, minus 3x, that's the second term, and then the last term was 1. What you need to do when you have sums and differences, integrate each one. So what is the integral of 2x cubed? That's 2x to the power of 4 divided by 4. What's the integral of minus 3x? That's minus 3x squared on 2. What's the integral of 1? The integral of 1 is x. Simplify, this is what I get. Same thing you're doing here. Now you have this expression. You realize that it is both sums and differences. What you need to do when you see sums and differences, you're still applying the rule, but you need to integrate each individual too. So what you should be asking yourself, what's the integral of 4x squared? Well, the integral of 4x squared would be 4x cubed on 3. You understand how I got that? Yes or no?
Yes, miss.
Yes, miss.
Jules, do you understand that? Yes, no? Do you? No, you don't. That's fine. All I'm doing, following my rule. This is my rule when I'm integrating indefinite integration. So I said I'm integrating the individual terms. What's the integral of 4x squared? That's what you should be asking yourself. All I have to do, use this rule. So A is 4, x, go back again, n plus 1. In this case, n is 2. That's 2 plus 1. And then you're also dividing by n plus 1. That's 2 plus 1. So that's my first term. I found the integral. I need to find the integral of the second term, which is minus 12x. So I just put that minus here. I follow my rule. So that's 12x